I was curious if I can solve the mathematical problem number 1 paper for just using calculus. Let's go if we can do it. The problem say like this. You have a sheet of paper. The sheet of paper will have some dimension, let's say x0 and y0. And you folder this point, and when you folder this point, you do something like this. You do something like this. This will be y0 minus certain quantity, alpha. This will be alpha, and this quantity now, it will be x0 minus something, let's say beta. Now, Pythagoras theorem say that this side, x0 minus beta square is equal L alpha square minus y0 minus alpha square. Or in other words, this is alpha square minus y0 square minus alpha square plus alpha square, minus 2 times y0 by alpha. Or in other words, this side is alpha 0, alpha 0 alpha. Let me erase here this alpha square. Okay. So this side is alpha square and alpha square will cancel. This minus will be a positive 1, 2 times y0 by alpha, and minus y0 square. So I have a triangle, right triangle, where this side is y0 minus alpha, this side is alpha, and this side it is x0 minus something square, should be 2y0 alpha minus y0 square. And I want to find A of alpha. What will be the area of the triangle? The area of the triangle will be the base, 1/2, the base, 2y0. The side is 1/2. So it's the base 2y0 alpha minus y0 square 1/2 is by the height. The height is y0 minus alpha. Now the challenge is, if I make the derivative of A respect to alpha, so I vary alpha, and I look for the minimum value of alpha. So I need to put the derivative of A in respect to the alpha equals 0. So the question is, if I write this equation and I do the derivative of A in respect to alpha, I put it equal to 0. Can I obtain the result that he has obtained in the PDF? I think so. So let's go to do it. The derivative of A respect to the alpha, we have to be careful doing the derivative. Here we have a product of two functions, so it will be 1/2. The derivative of the first is 1/2 2y0 minus 2y0 multiplied by alpha minus y0 squared, sorry, minus 1/2 by the derivative, internal derivative, and the internal derivative will be 2y0. Multiply by the second, the first by the second, plus the first, I'm doing the derivative, square 1/2 multiplied by the derivative of the second. The derivative of the second is minus 1. And this has to be equal 0. So, if this have to be equal 0, in the equation I can erase 1/2 here and 1/2 here. And I can put this to the other side. So it will be 1/2 of these 2 will go with these 2. So let's go to erase. It will be 2y0 alpha minus y0 squared minus 1/2 multiplied by y0 multiplied by y0 minus alpha should be equal 2 times y0 alpha minus y0 squared and everything 1/2. Okay. Now if we multiply all the equation by this term 1/2. So when I multiply in the right side, I will obtain 2y0 alpha minus y0 squared. And when I multiply by 1/2 here, I will obtain a 1. So it will be y0 multiplied by y0 minus alpha equal 2y0 alpha minus y0 squared 1. Okay. So now let's go to manipulate this equation algebraically. We should find the solution. y0 squared minus y0 by alpha equal 2y0 alpha minus y0 squared. So this will be 2y0 squared, this with this. And now it will be minus 3 times y0 by alpha equals 0. If I take common factor to y0, it would be 2 times y0. y0 that multiply 2 times y0 minus 3 times alpha. Let's go 3 times alpha multiplied by y0 equals 0. Conclusion, to be 0, this you need y0 to be 0, which is the paper cannot have a 0 area, or the solution is here. Solution is that this is 0, not when y0 is 0, it's not realistic, is when the second one is 0, which is 2y0 minus 3 alpha equals 0. Or in other words, when 2y0 equals 3 alpha. Or in other words, when y0 equals 3 half alpha. Now we check our result. How? We said that when we folded the paper, we create a right rectangle where this is y0 the height minus alpha. This is alpha, and this is something minus alpha, something minus beta that I read here, that is here, is 2y0 alpha minus y0 squared. Okay, so let's go to right here. 2y0 alpha minus y0 squared. Oh, sorry. 2y0 alpha, 2y0 alpha minus y0 squared. So, but alpha should be 2/3 of y0. So the triangle that we are talking is this one. y0 minus 2/3 of y0 is 1/3 of y0. Alpha is 2/3 of y0. And 2y0 alpha, and this will be 2y0 alpha, 2/3 y0 minus y0 squared. So it will be 4/3 y0 squared minus y0 squared. And 4/3 minus 3/3 is 1/3. 1/3 y0 squared. So our triangle is 1/3 y0 squared. So if I divide by y0, I create a new triangle, more unitary. The triangle will be 1/3. I'm sorry. Here is a square root. Square root of this and a square root of this, which is 1/3 of y0. 1 square root of 3 y0. Why? Because I didn't see carefully, this is x0 minus beta square. So x0 minus beta, that is the side, is the square root of this. Sorry for the mistake, should appear. Now I think that is more clear. So here, let's go to erase here. So here we have 1 divided by square root of 3 y0. And the height is 1/3 of y0, and the hypotenuse is 2/3 of y0. So the triangle that we are talking is a triangle with 1/3 for the height, 2/3 for the hypotenuse, and we should check if we have done any mistake by using Pythagoras theorem. Will be 1/3 square plus the other side 1 divided by square root of 3 square. This should be 2/3. If it's 2/3, we didn't make any mistake. 1/9 plus 1/3. And 1/9 plus 1/3 is the same as 1/9 plus 3/9. 1/9 plus 3/9 is 4/9. So, and the square root of 4/9 is the size of the hypotenuse. And the square root of 4/9 is 2/3. 2/3, the hypotenuse. So this is the solution. So the solution, the area of the triangle that have the maximum area is when you fold the triangle, this length y0 minus alpha in a way that you leave only 1/3 of the height here. 1/3 of the height of the paper. Remember the paper that I drew at the beginning. This paper, y0. So the area is when you leave 1/3 here, 1/3 of y0, and here you leave 2/3, no, 1 divided by square root of 3, 1 divided by square root of 3 of y0. I don't know why he has here a square, but it doesn't have any square here, for sure. Or because it's the square root. Okay. Square root of 3, y0 is here. Okay. Okay, it's here. So the area is maximum when is 1/3, 1 divided by 3 of y0. 1 divided by 3, so the paper have to be folded in a way that this will be 1 divided by square root of 3 of y0. So this is the area you can perform the maximum area when you fold in this way. Interesting problem. The solution that they have done, I haven't seen yet how they did it, but my first impulse was to use calculus to find the solution, and I saw that at the end of the problem they have the same solution. So it must be right. Thank you.